Hey guys, welcome back. Okay, when last we left off, we were working on getting a screen or a window up on the screen. And we're almost there. I don't think this episode should be very long because we've done most of the work already. I did notice, guys, before we get too far, just after I turned off the video last time, that I had misplaced a piece of code. This one right here is sitting inside the switch statement. That's not going to work. You don't want to do that. I didn't want to change it off camera, but make sure you take that default window procedure and stick it outside the switch statement. So that's supposed to go right there. So I did notice that bug. Okay, so when we left off, we had run into a bit of a dilemma. Not really a dilemma, but we had to make a decision about how to handle high-level, kind of globally accessible classes. So control window is probably our first one. So the deal is we want this to be accessible pretty much from anywhere in the program. Now, control window maybe isn't the greatest example because it's actually, this probably only needs to be accessible from a few places, but this right here in particular, the device context, is going to be needed to be grabbed by a few classes along the way. So just quickly, I want to go over like what some of our options are with regard to how to deal with this. The first thing that popped into my head when I decided we needed this guy to be accessible was a singleton. Now, singletons have fallen out of favor in the programming world in recent years, and for good reason. They were overused, they're misused, and I have to admit, I'm one of those people who overuse them and probably misused them. You know, in my opinion, there's a valid place for singletons in the world of programming still. If you are absolutely positive you only need a single instance of a class, and that class has to be globally accessible to lots of other classes, then I think a singleton is a perfectly valid programming design for that purpose. So I think there is a place for them. However, having said that, they are falling out of favor. People don't like them. They're almost getting as bad a rap as global variables. And so I sort of decided, well, maybe we shouldn't do a singleton. And in this case, since this class actually, it does satisfy the condition that we need just a single one. We only want one control window. Now we might want other windows, but they'll be child windows. So it is a single instance, but it doesn't necessarily need to be seen by every single, well, a whole bunch of different classes. Really, probably a handful of classes need to see this. Anyway, a singleton could work there. I decided to not use a singleton. Now the second possibility is to make this a static class. And now I put class in parentheses, or not parentheses, but quotes, because there's no such thing as a static class in C++. You can't do this, right? I mean, you can, but it's not going to do what you expect. That doesn't mean what you think it means. Okay. In fact, if I try to run that, I think it'd probably get a warning. Let's see. Yeah, there it is right here. Static ignored on left of game engine control when no variable is declared. So yeah, but when people say static classes, what they probably mean, and what I mean is when I say that, is that all the functions are static, right? Like this. Which means, if you don't know what that means, guys, it means that you don't actually have to make an instance of this class in order to access those functions. Now, the thing about static classes is static functions is any function that's static can only access member variables that are also static. So in this particular case, actually, what would happen? You see control windows here is erroring on us. That's because it's not static. So then I have to come down here and make this static in order to fix that. And that's just because of the way statics work. Because there's no instance of this class, You can't access something that needs an instance. So that fixes that. But since there's now no instance of this, you actually have to declare this variable up in here, right? I'm going to take this out. I think I added this after the video was over. You have to actually declare the variable up in here so that actually memory gets stored for it. And I don't really like static classes that much. I will use static functions when necessary, but I try to actually avoid them because they come with a certain amount of baggage. If they start making you declare things that are static, that doesn't make sense to be static, just to get the class to work. So to me, I try to keep away from them, to be honest. That's just me. So yeah, that's another option. I mean, a static function then can be accessed anywhere in the program. But to me, I don't love that kind of thing. So that was the second option I thought of. So the third option that we have would be to avoid the global variable thing altogether and define way up in here, there we go, control window, like CW. Actually instantiate it way up in the high level, like the entry function. So there's no global variables in that extent. That's fine, except here's the deal. Now you need to pass that variable down into your classes. Okay, and now the class tree could be quite extensive and long, and maybe you need the CW way down in a leaf way down in the bowels of the program. You need to pass that CW down across multiple classes, many of which really don't need it, and what you're just doing is a pass through so that it can be accessed to something a little further downstream, and that gets to be awkward, especially if you got a lot of them. So, I mean, this is one way some people get around that. If you really hate global variables, that's how you would do it. And that's valid. I mean, there's nothing wrong with that. It's just, I think it's awkward because you're passing all these extra variables down. You're really polluting your parameter space with a bunch of stuff that doesn't necessarily relate to any particular class, except it needs to be used by a class that's further down along in the class tree, right? So that's not my favorite solution either. So all these solutions have their pluses and minuses. None of them are perfect. So yeah, you're gonna have to pick one way and deal with the consequences of it. So there's a fourth way, and the fourth way is the way that I've ultimately decided we're going to go, and it's kind of a conglomeration of a lot of these different things. Okay. So what I'm going to do, guys, is I'm going to go to project, and I'm going to add a new item. I'm going to add a new class. Oops, no, that's not what I wanted. Project add class, that's what I want. I'm going to call this class, let's call it Global Manager. There we go. So this is good. So we got this class called Global Manager. It's a little bit of almost a misnomer. It isn't really going to be a global manager because we're actually going to almost deglobalize the global variables. What we're going to do is put our high-level classes that we need global access to in here. Now that's a little bit dangerous because this can have a tendency to become a catch-all kind of deal, which if you overdo that or over-abuse it, you start to lose all semblance to object-oriented programming. So you got to be careful and only put in stuff in here that really makes sense to put in. Okay, so this is going to be our static class. Now, I just got finished saying I have problems with static classes and I didn't want to really use them. In this particular instance, though, this is going to be a stateless class, or nearly a stateless class. The only thing we're going to have in here is instances of other classes. So otherwise, we're not going to have anything else in here. And then static functions which access those instances. So in order to make this a static class, what I want to do is I want to first of all make sure that there's no way we can instance this class. So what I'm going to do is for the constructor, I'm going to say delete. Now this is a new, actually I might as well do it for the destructor as well. That should do it. Let's see. Let's do the assignment operator as well. Constant global manager source. I mean, I'm not actually sure this is even especially necessary. Did I mess up something here? Yeah, I didn't put an equals. Because if I don't have a constructor, there's probably no way I can actually ever instance this. That might be just enough, but just in case, I mean, you know, it doesn't hurt. So let's put in the copy constructor. Let's make it constant, just because I like to stay consistent. Speaking of constant, we'll deal with that in a minute as well. Delete. And then just for we'll do the same deal for the move assignment operator, and also for the move constructor. What am I doing? Delete. Okay, now there's, let's see, 1, 2, 3, 4. So those are your 6 auto functions. Now I've deleted all of them, which is probably way overkill. You probably don't need to actually do that. But now there's absolutely no way Global Manager can ever be instanced. If I try to instance Global Manager anywhere, it's just not gonna, it's not going to work. Let's see. It's not erroring on me. Wonder why that is. Okay. Very nice, guys. Okay, so we're back to this issue with the control window. We've kind of built a skeleton of a class that cannot be instanced. So now what we want is here. Let's do the private. Let's create an instance of our control window class. Control window. You know what? I think I might need to rename that. Control window. Okay. Yeah. I don't like what I did here. Okay, I'm gonna double click this, I'm going to right click, and I'm going to rename this. Let's see, where's my rename? There it is. Control window class. Yeah. Thank you. So that'll automatically rename the entire thing. Hopefully it's got everything set. And then this should be happier, one would think. The other thing I'm going to do, let's see. I'm going to rename the actual files. Okay. And then we got to fix this. Although actually we shouldn't need that, to be honest. I'm going to change this to Global Manager. Oh no, never mind, sorry. No, not here. That's not where I want to change that. Okay, we should be pretty good. It's not liking control window class. That should fix that. Semicolon, there we go. There we go, now it's happy. Let's see. Let me think about this for a second. I think we actually probably should put this in the namespace as well. There we go. Alrighty, now if I do that, I shouldn't actually need to have the using namespace anymore. It should just do it. Yeah. I think I like that better. We really shouldn't need to put in using namespace all over the place. Okay. All right, so there you go. We've got an instance of our control window class right here. It's a static. So now, however, it's private. Now, you could make this public, guys, and just directly access it like this. I'm kind of militant about not putting member variables as public. I will leave them private, or at the very most, I'll make them protected. And usually not even that. I personally think it's a good idea to keep your global member variables private and use accessors like we're about to do. I really like the properties in C# that do this automatically for you. Let's say control window. Okay, so there you go. We've got this function. Now we just need to implement this. Okay, yeah, we need to delete these. These are the constructors and destructors, and remember we deleted them, so we can't actually define them once you delete them, right? That will lead to an error. Okay, there we go. So let's return the control window, like such. Oh yeah, let's take the static out. Yeah, sorry. Confusing myself. There we go. That should work. There we go. Now it's happy. Okay. Very nice. All right, guys. So there you go. We've set it up. It should be fine now. I think that should work. Now we need to go back to WinBase, and instead of using control window, we're going to use global manager. And that should be fine. Okay, so up here in the, just before the message pump, we need to say global manager. Get control window dot create control window, and we need to send the instance. So we'll do that. There you go. So now we've created the control window. We need to modify this. So this is going to say global manager get control window dot destroy control window. There you go. Now everybody should be happy. No, you should be happy. Remember when I said you should be happy? Be happy. Here, let's try to build it. Ah, right. Okay. So one more thing we got to do, and I mentioned this before. So because this is now static, there's no actual memory allocated for this. So in order to have memory allocated for the actual control window, what we need to do is almost make it look like a global variable up in here. So let's see, let's put those here. So this is going to say control window class, global manager control window, like such. So this is your actual instantiation of this class. Okay, so it still is private, even though it kind of looks like a global variable sitting out here outside the class. It still has the access restrictions that a private variable would have. So the only person, or the only class that can see this is this class right here. Okay, so that should build. Oh, by the way, guys, I did stick the build menu up in here, and to do that, so instead of having to go project or build solution, it's just right here. And to do that, I just went to, I think it's under tools, customize, and it's right here. Just click that on and it'll put it up here. And you can actually move these around. You can put them over here, or put them down here if you prefer down there, wherever you want to move stuff around to, whatever is best for you. I just left it over here. Okay, are we missing anything? I think that should run. And we actually have a window. There you go. Ta-da! Oh yeah, by the way, I was reading this wrong the other day. Again, this is the result of me being away from the compiler for a while. This is time along this axis, so there's no building up of memory. It's sitting at 1 megabyte for the program. The vast majority of which is going to be the stack, because we really haven't allocated a whole lot of memory. And you can see the CPU is sitting at 0%, which is good. Now, like I said before, if I were to drop this out, which should end up happening, and it actually doesn't hit 100%. Used to be once upon a time, if you took that out, this would hit 100%, for sure. I suspect now, because of the multi-core CPUs, it's not going as high anymore. It's probably, I don't know how many cores I have in my CPU. I think it's 4, or maybe 8. I don't remember. Sorry, guys. Anyway, you can see it's actually much higher since I removed that sleep. So this just prevents that from using too much of the CPU. Okay. All right, guys, it works, and we're good, but I want to clean this up some. I've done some things that we need to clean this up. It's a little bit of a mess in certain places. So let's start. Let's see. What do I want to fix here? I've actually gotten a little bit lazy with the declarations. Let's put in our variables where needed. This isn't absolutely required. But I mean, if you're looking at the declarations, it's nice to be able to see the variable names that you're going to use, in my opinion. So I'm going to just put those in instead of leaving them blank like I've done here. So that should be fine. Yeah, I think that's all good. Yeah, I think everything's fine here. I don't see any issues. Let's see, engine base is good. Global manager should be fine. I think we've got constants where we need them. And same here, this is good. Okay, control window class. This might be where I think I might need to clean up. Yeah. Okay, we've got a variable that we're using here. Let's put that in. That's fine. We've got these empty functions here. Let's get rid of those. Yes, default, please. Default. So they're not taking up space in the class. That's better. Okay. All right. Do you not like that? Nothing wrong with that code. Stop it. Okay, there you go, guys. I don't know why the compiler was freaking out over the fact that I took out the constructor and the destructor, but I told it to make them default, so I don't know why it was freaking out. Okay. It's all good. Yeah, it's all good. All right, so we have, let's see, okay. All right, guys. Maybe let's do one other thing. This is okay, except we dumped it up at the top left corner. Let's see if we can center that. Let's just make our control window class a little bit more intelligent. So let's see. After the register class, yeah, let's put it here. So let's get a screen height. Screen x equals get system metrics. That's the one right there. And the system metric we want is SM. I think it's called CX screen. Okay, tell you what, int screen x, int screen y, there we go. That should be happier. And then screen y equals system metrics smcy screen such. Okay, so we got it. We got a screen height and a screen width. Let's see. We're going to create the control window. Okay. Yes. Okay, we've made this 500 by 500. Tell you what. I'm going to drop this down underneath the control window creation instead of putting it up there. And then I'm going to say, now we should know, we know how the window height, but just to make it, just in case something changes for some reason, let's do this. Get window rect. Then we need the control window handle. And the rectangle. And we'll just call this window rect. Which we'll put up here. Okay. All right, so that should be good. We've got the screen size, we got the window size. That should get us the ability to set the window. Set window position. So we need the window handle. Control window handle. Window insert after. We don't need to insert after anything. So the X. All right. So we want to center this. And now in the X direction, what we want is to get the center of the screen. So that's going to be screen X divided by 2. And we'll subtract off half the window X size. So window rect No. I just realized we need to make a slight adjustment. So let's say window X divided by 2. Oops, divided by 2. All right. And let's put those in parentheses. All right, it doesn't like that. So int window X, int window Y. Okay. What we've got here, when we get the window rect, is a rectangle into the window. It's going to have the upper left corner position and the lower right corner position. Now the upper left corner position should always be 0. So technically this probably isn't necessary, but just to make it equals window rect dot. So we're doing, let me think here, we're doing the X, so we need the right minus window rect dot left. Okay, so that gives you the actual size of the window. Now, technically, guys, window left should always be equal to 0. So really, we should just be able to take window right. However, so this is going to be window rect bottom minus window rect dot top. And the same thing. Now, why am I going through all this issue. I mean, technically we can pull it straight out of there. We know it's 500, right? I could replace this by 250 right here and be perfectly fine. But if we change this, and this is where I'm heading with this. If we change this to some unknown variable, then that's no longer the case. We got to come down here and change this, and you don't want to change it in multiple places, right? You just want to change it in one place. So this automatically gets it for you. So no matter what I change this to, this will now be correct. And again, like I said, technically left and top will always be equal to 0. So technically we wouldn't necessarily have to do this. We could just use Windows rect right and Windows rect bottom, but that's not what they are. From an object standpoint, this means a different thing. This means the right side of the window, whereas window X is actually the width of the window, right? So I mean, yeah, I mean, technically it might not be totally necessary, but I'm going to do it anyway, and you guys can deal with it. Let's see, window Y over 2. Okay. CX and CY. So this is the new window height and width, or width and height. If you set these to 0, it'll just leave it alone, which is what we want. And then I'm in here for the flags. I'm going to put SWP no size. That'll prevent it from changing the size of the window. I'm going to order that with SWP no Z order, because we don't want this changing order on the screen. Okay. All right, that should, if we run this, see if I did this right, it should center the window on the screen. There you go. So instead of being stuck way up here in the corner, it's now in the middle of the screen. So that's pretty good. Okay, one more adjustment I want to make to this. At this point, we've kind of locked in the window size, and I'm not super happy about that. What I want to really be able to do when I create the control window is actually specify up in the parameters width and a height, right? Did I do this? I think I should make this a constant. We don't want to modify instance. We probably don't want to modify width and height either, for that matter. We'll see. So there's width. There's height. So now we can make it whatever size we want just by passing in the parameters. What we should do on this section though, okay, so that would mean, all right. I'm going to put in some sanity checks here, and to do this I'm going to have to move these back up on top of the control window. Let's see if screen X is less than the width, then width equals screen X. I'm just preventing the specified width and height from being bigger than the actual screen. So if we pass in a height that's too big, it'll actually reset it to the size of the screen. Screen Y, like such. Which is good. And for that reason, we're not going to be able to make these constant. Oops, I didn't put that there either. Okay. The age instance should definitely be constant. We definitely do want to make sure this never gets changed. The instance is coming from someplace else. It should never change. So that should be good. We're all good there. So is that going to work? Oh, no, you know why? Because I did not fix this. All right, so now when we create the control window, we can actually say, let's make it bigger. Let's make it 1,000 by 1,000. You can give it actual numbers straight in here. And if we ever need to change it, we can easy change. All right, that should work. Let's see how that looks. There you go. Let's go to height of 500. That seemed a little big. So there you go. I mean, you know, you can play with it. Just to give yourself a reasonable size. Now, because of that whole default window thing, I can actually move this and change it to be whatever I want, right? We don't necessarily. It'll do all the usual default window kind of things. We got a system menu over here. We can minimize, or we can't maximize. There's no maximize on this. I could set it up to have a maximize, but we don't really need it. And close. All right, very good. Very good, guys. I'm pretty happy with that. I'll leave that alone. Technically, this might need... We could make that constant. I'm not sure if it's going to like that or not. I don't know if you can mess with the win main. I guess you can. All right, fair enough. Again, instance should be constant. It's being passed in by Windows, that whole thing. Okay, guys, I'm pretty happy with that. I don't think there's anything else I really want to change. I do, how are we doing here? Oh, we're getting long. There's one other thing I want to fix, and that's this business over here. All this mess. Now, the default, the compiler has set up some default filters for us. What I call folders, but what the compiler calls filters. And it's put header files in one section and source files in another and resource files here. And all this is fine and well for small projects. But that's actually, when you're getting into larger projects, we're going to have a lot of classes, a lot of files. This is probably not an ideal setup. I prefer my own solution to this. So what I'm going to do is right click on game engine. I'm going to, I should be able to add a filter. Yeah, new filter. There we go. What I'm going to do is create a new filter called base. And I'm going to take everything that we've built so far and drop it in, as well as the C++ files. Because everything we've done... Hey, what are you doing? Into base is where I want you. Because everything we've built right now is the base part of the program. But ultimately, we're going to add different filters to this. Yeah, we'll just leave it at that. So the header file I'm going to delete. We don't need this anymore. Same for source files. We don't need this anymore. I'll go ahead and take out resource files as well. We may end up putting it back in later, but for right now, we don't need it. Okay, we'll leave in references, even though there's nothing in here for the moment. That's sort of an automatic thing. Now, external dependencies. We've got all these external dependencies. Now, you might wonder what all this is. This is coming exclusively from, let's see, Windows H. If I were actually to remove this, which should end up happening, see, external dependencies are gone. So if you ever wonder where all this is coming from, it's from Windows. Windows, there's a lot of functions in here, and if you look at this code, really, guys, a lot of this stuff is not C++. It's coming from Windows, from that header. Create window, all these, pretty much everything in purple, really, just about. Load icon, just dark gray brush definition, all these things. This is not C++. It's from Windows programming, so it's coming from that header. So yeah, that's what all these dependencies are. Anyway, okay, so we've cleaned that up. This looks good. We're constant correct, I think, throughout the program. I don't think there's any place that I've missed, unless I have. We really only have 3 CPP files at this point, and only 2 of them really have code. I could probably make these constant, although again, the window, I'm not really positive about this. I've never really messed with the Windows default functions before, but I don't see why that wouldn't work. You probably don't want any of these to change ever. I've never seen anybody do that, but actually, technically, to be honest, they should probably all be constants. So maybe we'll do that, and it should work. I mean, if you want to be hardcore about your constant correctness things, that's probably how to do it. Same for these, really, but we're not using these. The only one we're using is this one right here, the instance. So, okay, I think we're good. I don't think there's anything else I want to mess with at this point. We've got a fairly intelligently designed control window creator. We've released the device context and destroyed the window. Yeah, I guess I'll stop here. We could throw in a switch to catch the escape key, to destroy the window when you hit the escape key, which, yeah, doesn't happen right now. There's no reason why it would. I haven't put it in there. Pretty easy to do, but we're getting kind of long. Yeah, maybe I'll leave it for another time. Okay, guys, so we'll stop here. In the next episode, we'll start talking about implementing the classes for the memory manager. So that should be interesting. All right, so I will see you guys in the next episode. Thanks a lot.